Hello! In this video, we are going to prove the following theorem. Suppose A, B, and C are real numbers. Then A is greater than B if and only if A plus C is greater than B plus C. Now, in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now, before we prove this theorem, we are first going to prove the following preliminary result. Suppose A, B, and C are real numbers. Then A minus B is equal to A plus C minus B plus C. Now, to prove this result, we are going to be using the following axioms. Axioms 1, 2, and 3 are just the commutative, associative, and distributive laws. Axiom 4 tells us that there exists a real number, which we call 0, that has the property that x plus 0 is equal to x for all real numbers x. And axiom 5 tells us, for all real numbers x, there exists a real number, which we call the negative of x, that has the property that x plus the negative of x is equal to 0. Now, we're also going to be using the following fact, which we have proven. We have proven, for all real numbers x, negative 1 times x is equal to negative x. And our definition of subtraction is as follows. Suppose A and B are real numbers. We define A minus B to be A plus the negative of B. Okay, so now let's get into proving this preliminary result. And to prove this preliminary result, we're trying to show that these two guys are equal. And to show that these two guys are equal, we're going to establish a chain of equalities showing that these guys are equal. And through that chain of equalities, we are going to be applying axioms 1 through 5, star star, and the definition of subtraction. First of all, by definition of subtraction, A plus C minus B plus C is equal to A plus C plus the negative of B plus C. Then, by star star, the negative of B plus C is equal to negative 1 times B plus C. And then, applying axiom 3, if we distribute negative 1 across this parentheses, we get negative 1 times B plus negative 1 times C. But then, by star star again, negative 1 times B is equal to the negative of B, and negative 1 times C is equal to the negative of C. And then, applying axiom 1, we're going to swap negative B and negative C. And then, applying axiom 2, we're going to move these parentheses around A plus C plus the negative of C. And then, by axiom 2 again, we're going to move these parentheses around C plus the negative of C. And then by axiom 5, C plus the negative of C is equal to 0. And then by axiom 4, A plus 0 is equal to A. And then by definition of subtraction, A plus the negative of B is equal to A minus B. So, through this chain of equalities, we have shown that A minus B is equal to A plus C minus B plus C, which is exactly what we wanted. So this proves our preliminary result. So now our next goal is to prove this theorem. But before we get into proving this theorem, let's get a little bit more context. Now, our real number system is equipped with a subset that we call the set of positive real numbers, and it's denoted as R plus. And using the set of positive real numbers, our definition of greater than is as follows. Suppose A and B are real numbers. We say A is greater than B if A minus B is a positive real number. Okay, so now let's get into proving this theorem. Now our whole goal is to prove A is greater than B if and only if A plus C is greater than B plus C. And to prove this, we're going to establish a chain of if and only ifs, showing A is greater than B if and only if A plus C is greater than B plus C. And through that chain of if and only ifs, we're going to be applying star and the definition of greater than. First of all, by definition of greater than, to say that A is greater than B is equivalent to saying A minus B is a positive real number. But according to star, we know that A minus B is equal to A plus C minus B plus C. So to say that A minus B is a positive real number is equivalent to saying A plus C minus B plus C is a positive real number. But then, by definition of greater than, to say that A plus C minus B plus C is a positive real number is equivalent to saying A plus C is greater than B plus C. And so, through this chain of if and only ifs, we see that A is greater than B if and only if A plus C is greater than B plus C. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.